Okay, next big myth. Use of multi-well pads reduces surface impact. You've heard that. Hey, because we have directional drilling and because we have multi-well pads, we don't need as many pads. We can now have the pads roughly a mile apart. And we can have many wells in that one pad, and that's going to reduce the surface impact. Fewer roads, right? One pipeline going to be servicing one place instead of 16 pipelines servicing 16 different places. It all sounds great. There's an element of truth to it. All myths have an element of truth. Let's look at the rest of what surrounds that element of truth. My favorite slide. I've used this, and I have to admit, I've used this slide in just about every talk I've given for the last year because it's so instructive. It's not only instructive, it's crystal ball gazing. It's telling you your future. If you want to know what your countryside is going to look like 10, 20 years from now, watch the next 3 slides. It's the closest I can come to predicting your future. How do I know that? Let's do a hypothetical experiment. It's not really hypothetical, it was done. Let's imagine that a single operator, one company, in this case it happened to be Chesapeake, was able to negotiate a lease with a single landowner. Didn't have to go to what we call compulsory integration in New York. What do you call it down here? Forced pooling. Didn't have to compete with any other operators for your attention. Didn't have to bid up the lease price. They had one entity, in this case the Dallas-Fort Worth Airport Authority, in which they negotiated a single contract. So one company negotiated with one landowner and got everything they wanted. And what they wanted was the Dallas-Fort Worth Airport. This is a map of the Dallas-Fort Worth Airport. You all recognized it, right? It's the Dallas-Fort Worth Airport. It's 53 pads. Each one of these red dots is a pad. 18,000 acres, that's roughly 30 square miles. Each one of these red lines is a well. And you'll notice that there's almost complete coverage of that Barnett Shale formation underneath the Dallas-Fort Worth Airport. They got almost all the gas that was available. I don't know what percentage, but a lot of it that was available under the Dallas-Fort Worth Airport. What you see here is the combination of those 4 technologies. Directional drilling, long laterals, slick water, high volume, multi-well pads. This is the way, ideally, the gas companies would like it to work everywhere. Can this happen in Pennsylvania? Is it happening in Pennsylvania? Some places, but remember, you're only 2.5% of the way into a 100,000 well play. What you see in Pennsylvania right now is the proverbial tip of the iceberg. I submit that this is much more likely, ultimately, what you're going to see wherever companies can negotiate the kind of agreement that they got here. All right, here's another look into the future. As you know, many of the pads that have been developed, on which there are wells that have been drilled, some of which have been fracked, some of which are in production in Pennsylvania, are single or multi-well pads. Some of them only have a single vertical well, some of them have a single vertical well and a single horizontal well, some of them have a vertical well and a couple of horizontal wells. Very few of them so far have 4, 5, 6, 8, 10, 12, 14, 16 wells, but eventually most of them will have a large number of wells, 6, 8, 10, 12. Why? Because the industry is finding out by doing experiments elsewhere that that is the most economical way of doing things. If you have to bring the big rig to one place once to drill multiple wells, that's a lot better than having that big rig here today, 5 miles away tomorrow, another 5 miles away the next month, and then it has to come back sometime in the future to drill the second well. That's moving all your equipment around. That costs money. Same thing with the fracking equipment. Okay? So to optimize things, it's better to do everything at one time in one place, except that one time now becomes elongated. Okay? So this is what was, about a year ago, the largest frac job ever done by anybody. It was done by Apache in northeastern British Columbia. As you can see, it looks a little bit bigger than the pads you've seen in Pennsylvania so far because there's 16 wells on this pad. They're actually being fracked at this point in time. So the surface impact here is negligible. Would you call this heavy industrialization? I would. How long does it take to drill 16 wells and frack 16 wells? Here today, gone tomorrow? No? A month? A year? A couple of years? And when that's all done, what's left? One little wellhead and one little 500-gallon plastic tank? No, you got 16 wellheads and you got a series of very large tanks collecting brine for a long period of time. So the surface impact is larger, the remnant surface impact is larger, the industrial impact is larger, the equipment is larger, the period of time that this is under active development is larger. You be the judge of whether the impact is less. This is another image similar to the one I showed you in cartoon style of the Dallas-Fort Worth Airport. Again, this is northeastern British Columbia. You'll notice that each one of these convergence points is a pad, and from each pad there is a number of wells, and we're going to focus on this one. There's 16 wells that came out of this pad. Notice that all the wells are either going in one direction or in the opposite direction. Why? There's another mini-myth here. I'm managing to eject a bunch more mini-myths. One of the mini-myths is, well, because of directional drilling, we can put down a pad here and we can drill wells in all directions, 360 degrees like spokes of a wheel. How many times have you heard that from a landsman? Right? Wrong. Geologically stupid. The fracture patterns that I showed you, that are the fracture patterns we're trying to reopen so that they're superhighways for the gas, those fracture patterns are given to us by geology. 350 million years of fracture formation, they are what, and you want your well to be oriented perpendicular to one of those joint sets, and that means your wells are all going to go more or less in one direction or in the opposite direction, which is the same direction geologically speaking. Okay. So you see that pattern. You've seen it twice already, Dallas-Fort Worth Airport, this case. So let's zero in on this pad. This is now the world's largest frac job. And I submit you're more likely in the future to see things like this in Pennsylvania when the companies realize that they no longer have to hold on by just doing one well here and then having to go someplace else to hold on to another lease. When all that settles out over the next few years and companies can really optimize the process, they'll be doing bigger pads with more wells at one time. This is the world's largest. It's an Encana pad. Here, the details, 16 wells, 417 million gallons of water, 78,000 tons of sand, 8 million gallons of fracking chemicals, 500 frac intervals, 10,000 foot long laterals, 40,000 horsepower pumps for fracking. I don't call that minimizing surface impact. Do the best I can to project this or that onto an area of Pennsylvania. I happen to randomly pick this area so that it scales. And so if we were to map that process, that technology of using those four methods for optimizing the development of a shale gas well, each one of those yellow rectangles would be what we call in New York a spacing unit. I don't know what you call them down here. An area the company has gotten a permit in which to develop all of its wells because they got landowner permission. So each one of these yellow rectangles would be an area in which one company would put down a pad. The red square is a pad. They would then drill 3, 4, 5, 6, 7, 8 wells, roughly north-northwest, turn around and drill 6, 7, 8, 9, 10 wells, roughly south-southeast. And this pattern would repeat itself in an ideal situation. If one company could get all the landowners in this area to agree that this is the way they would like to see their land used and their gas developed, then this would be the ideal from a geological point of view, from a production point of view, from a cost minimization, optimization point of view. This is what it would look like. Is this likely to happen? Depends upon you, depends upon landowners being willing to engage with companies to allow this density of development. But the industry can have it both ways. They can't claim that there's 40 years supply of natural gas under Pennsylvania, that there's 489 trillion cubic feet of developable gas in the Marcellus Formation, and not have hundreds of thousands of wells. So another mini myth that we're starting to hear up in New York is that, nah, you're not going to see a lot of wells. Well, if you're not going to see a lot of wells, you're not going to see a lot of gas. So you can't have it both ways. You can't say we're going to solve the nation's gas production problems for 100 years and only have a few thousand wells. There is no such thing as a miracle well that produces 100 billion cubic feet of gas over its lifetime. Okay. So the myth, the use of multi-well pads reduces surface impact. There's an element of truth there. You have fewer pads. But does that really reduce surface impact? Well, what do you mean? Over a period of time? Do you mean there's less total industrialization? Do you mean the total number of trucks driving down the same road is less impactful than the same number of trucks driving down 8 roads? Do you get less dust from those roads? Do you get less noise? Do you get less diesel? I don't think so. So the use of multi-well pads facilitates and prolongs intense industrialization and leaves a larger long-term footprint. That's, in my opinion, the truth of what's going on.